All right, welcome to lesson 7. This is going to be a pretty big couple of days. We're going to be learning a new concept that's going to be really helpful in understanding and evaluating different characteristics for polynomials. So make sure that you take your time with this. It doesn't come easily. It's kind of a tricky concept at first, but it's all rooted in common sense. So as long as you put in time and effort, you will undoubtedly master it. Let's go ahead and get started. Alright, so go ahead and work through the discovery problem, copy it down, answer parts A, B, C, and D on your own, and then we'll discuss. Is 0 a root of the function? So we notice we have this cubic polynomial. That means we know the end behavior, but do we know any of the roots? Well, if we were to plug in 0 for x, would our function go to 0? Right? That's basically what we're asking. Unfortunately, we don't have this in factored form, right? So it's not clear that I'd be multiplying 0 times something else. I'm adding here. So I've actually got to plug it in and try it out, right? So if I plug in 0 for x, I'd get 0 cubed plus 7 times 0 squared plus 10 times 0. Well, 0 cubed is 0, 0 squared is 0, so 7 times 0 squared is 0, and 10 times 0 is 0. So I have 0 plus 0 plus 0, which is 0. So yes, x equals 0 is a root. Well, that means we have a linear factor, right? Because we know that if we write this in factored form, when we plug in 0 for x, one of those factors has to be 0. So one of our factors is going to be x. This leads us to try and write the function f of x as this linear factor times whatever's left over. Well, if I'm going to be multiplying x times something, and I'm going to end up with x cubed plus 7x squared plus 10x, it doesn't make it too hard to figure out what the other terms need to be. X times what is x cubed? X squared. X times what is 7x squared? Well, that'll be 7x. And x times what will be 10x? Well, that's 10. So now we notice just by finding one linear factor, I'm actually able to go through and rewrite my function in a slightly more factored form. But notice I still have this x squared plus 7x plus 10. That's not so fun. It's a quadratic, and we like linear factors. So what are the other linear factors of f? Well, they're certainly not going to come from this piece here. This is already a linear factor. But x squared plus 7x plus 10, that's actually factorable, right? I can think about two things that multiply together to be x squared plus 7x plus 10. X times x would get me x squared. And then I need two other terms in my binomial here that need to multiply together to be 10, but also add together to be 7. So I have 2 and 5. Well, now, notice that I've found the other linear factors. I have all three now. So what are the other roots? Well, I know if I plug in 0, the whole thing will be 0. And now it's easy to figure out what these two linear factors, what x values make those go to 0. -2 and -5. So the other roots are x equals -2 and x equals -5. Now notice what we've done. We started with a polynomial in standard form. And by taking some of the information that we were given and testing, to see, did we have a root? If we had a root, could we tell, what the linear factor would be? We were eventually able to figure out all of the linear factors of this polynomial, which was really useful because then I could find all of the other roots. And of course, the roots of a function are a key characteristic, and so using those, we can easily sketch a graph or make sense of the situation. And so our goal is going to be to find these linear factors. It's not always going to be this easy. Okay? As we'll see coming up, there might be situations where we don't end up with x squared plus 7x plus 10. It's a little harder to do. And so we're going to come up with a way of finding these linear factors. Okay, so we want to remind ourselves a little bit about factors and what makes something a factor and what leads it to not be a factor. go through and just copy down the question part here, and don't worry about writing these out. Just answer these in your notes next to where you computed this quotient. Okay? So let's start with 35 divided by 5. That is 7. And that tells you that 5 is a factor of 35. Why? Well, because 35 has 7 5s in it. It has a whole number of 5s in it. In other words, we can write 5 times 7 equals 35. 35 divided by 6 is not so nice, though. Notice that how many times does 6 go into 35? Well, it will go in 5 full times. But then I have to add on a little bit to get all the way to 35, right? 6 times 5 is 30, so I'm going to have a remainder of 5. So is 6 a factor of 35? No. Why? Well, because 6 times 5 plus 5 is 35, right? It doesn't go in a whole number of times. All right, what about x squared divided by x? Well, just like we did here, we asked ourselves, what would I multiply 5 by to get 35? You can do the same thing here. What would I multiply x by to get x squared? Well, x times x is x squared, and that will get me exactly to x squared. So is x a factor of x squared? Yes, because x times x is x squared. Notice that polynomials, this is a polynomial, they behave just like regular numbers. X plus 2 times x minus 2 divided by x plus 2. Okay, well let's go back to what we talked about here. How do I know what 35 divided by 5 is? I thought about what would I multiply 5 by to get 35? Well, I'd need 7 of them, so I'd multiply by 7. Okay, well what would I multiply x plus 2 by to get x plus 2 times x minus 2? Oh yeah, that's pretty obvious, right? X plus 2 times x minus 2. Well, I'd have to multiply x plus 2 by x minus 2 to get x plus 2 back. So is x plus 2 a factor of x plus 2 times x minus 2? Yes. Why? Because x plus 2 times x minus 2 is equal, of course, to x plus 2 times x minus 2. It's redundant, but it gets the point across. All right, what about x squared minus x minus 6 divided by x plus 2? Let's ask ourselves the same question. Is there anything that I can multiply x plus 2 by to get x squared minus x minus 6? Well, let's think about it. If you remember how to FOIL, how to multiply two binomials, you know that if you had x plus 2 times x minus 3, and you multiplied those two together, you would get x squared minus x minus 6. So we can say x plus 2 is a factor of x squared minus x minus 6, because when I take x plus 2, I can multiply it by x minus 3. I don't have to, notice there's no remainder here, I don't have to add anything on to the end. It will go in perfectly. X plus 2 times x minus 3 will give me exactly x squared minus x minus 6. So the big idea here is, just like we do with numbers, we can think about whether 5 is a factor of 35 by asking ourselves, well, can I multiply 5 by anything that is a whole number to get 35? Does it go in evenly? With polynomials, we can ask ourselves if something is a factor by saying, is there anything we can multiply it by to get this bigger polynomial? And if we do, if we can find that, then that means this is a factor. And that's actually very powerful, because we found that factors can tell us a lot about the polynomial itself. So let's go ahead and apply this to a slightly more complex situation and see if we can't come up with a way of finding these factors all the time. Okay, a polynomial function f is defined as f of x is equal to 3x squared minus 12x plus 9. And the question is x minus 1 a factor? Before moving forward, just take a minute and answer the question, what would you need to do in order to show that x minus 1 is or isn't a factor? All right, hopefully you decided that you should divide. And if you're having trouble figuring that out, I'm going to go back to our previous situation with numbers and ask you the question, is 5 a factor of 35? Well, how do you know? You took 35, you divided it by 5, and you got 7, which means that 5 times 7 is 35. So, yes, 5 is a factor of 35 because it goes in a whole number of times. There's no need to add on anything at the end. You just multiply it by 7. So let's apply that same idea here. If we want to know if 3x squared minus 12x plus 9 has a factor of x plus 1, or x minus 1, we'll take 3x squared minus 12x plus 9 and divide it by x minus 1. It is very important when we divide polynomials by another polynomial, which is what I'm about to do here, that I am constantly keeping in mind what exactly I'm trying to figure out. And the best way to remember that is to think about what we're doing when we're dividing regular numbers. So if I take 35 and I divide it by 5, what I'm asking myself is, how many 5s go into 35? Or in other words, and this is the way that I like to think about it, what would I multiply 5 by to get 35? The answer, of course, is 7. And this number here is known as the quotient. When I take my quotient and I multiply it by my divisor, I'm going to get the dividend. Those are the words that we use to represent and talk about division. But the big key is we want to think about is if I'm dividing 5 into 35, I'm trying to find the number that I multiply 5 by to get 35. So when I'm finding the quotient here, I'll be doing the exact same thing. So what we're going to do is we're going to use the division algorithm in this exact same manner to find what we'd multiply x minus 1 by to get 3x squared minus 12x plus 9. So let's go ahead and do that. So I've written the polynomial division as a quotient, and now I've written it using the division algorithm. So thinking the same way that I did back here, we're going to go through and figure out what is it that I would multiply x minus 1 by that will give me 3x squared minus 12x plus 9. One way to help me envision this is to think of it as just another polynomial being multiplied by x minus 1. When I multiply, I'm going to have to distribute. So I'm going to take x and multiply it by all the terms of this polynomial, and then I'm going to take negative 1 and multiply by all the terms of this polynomial, just foiling. And so now my job is to figure out what would I multiply x minus 1 by that will give me this. Well, notice, what am I going to get 3x squared from? If I got 3x squared when I multiplied negative 1 by one of these terms, that would be a problem, because then when I multiply x by one of those terms, I'm going to get x cubed, because this already has a degree of x to the 1 and this doesn't. So what I want to think about is what will I multiply x by to get 3x squared, and then worry about what happens when I multiply by negative 1 later. Well, x times 3x will be 3x squared, and so the first term that I want to have in my quotient is going to be 3x. 3x times x would be 3x squared, but don't forget I also have to multiply it by negative 1. Now my goal is to see, just based on this first term, what will I have after multiplying by x minus 1, so that I can figure out what's left over from my eventual polynomial that I want to get. So let's multiply it out. 3x times x is 3x squared. And then 3x times negative 1 is negative 3x. So this is what I end up with after multiplying x minus 1 by this first term. So I'm not quite there yet, right? Notice if I'm comparing these two, these are the same, so that's good. Here I want negative 12x's, but I currently have negative 3 of them. So how many more do I need? I need negative 9x's more, because negative 3x's minus 9x's would be negative 12x's. I also am going to need plus 9, but I don't have any of those, so I'm going to need plus 9. What I want to do is I want to represent taking away what I already have from what I want to get so that I can focus on what's left over. Well, the way that I do that is by subtracting. So I'm going to subtract away what I got from this first multiplication. Because I'm subtracting all of it, I put it in parentheses and then distribute the negative in so that I can accurately subtract from both. So this is going to become negative 3x squared, and then a negative times a negative would be a positive 3x. Make sure I cancel that out so I know that I've distributed it in. 3x squared minus 3x squared, those cancel, and that's just 0. Now I have negative 12x plus 3x, which is negative 9x. And that's exactly what we said we were going to need, right? We need negative 9x's more. Also notice that I have none in the ones column, right? And so I have 9 minus 0, which is going to be 9. So plus 9, positive 9. And that's exactly what we said was going to be left over after we multiplied x minus 1 times 3x. So now we've got to figure out what will we multiply x minus 1 by so that we get this part that's left over. Again, we want to focus on x because when we multiply something by x, that's going to give us the highest degree in our multiplication. So what do I multiply x by to get negative 9x? How about negative 9? So 3x minus 9, well, that's going to be perfect because when I multiply negative 9 by x, I get negative 9x's. When I multiply negative 9 by negative 1, I get positive 9. And that's exactly what I wanted, right? It matches up perfectly. So I want to represent that I don't have anything left. So again, I'm going to subtract. And I'm going to distribute the negative in, and that's going to make this positive 9x minus 9. Cancel that out so it shows that I've distributed it. Now, negative 9x plus 9x, those are opposites, of course, like we just talked about, so those are going to cancel. Plus 9 minus 9 is also going to cancel, which means how much do I need to get still? Absolutely 0. Meaning that when I multiply 3x minus 9 times x minus 1, I'm going to get exactly 3x squared minus 12x plus 9. Go ahead and try that just to make sure. X times 3x, 3x squared. X times negative 9 will be negative 9x. Negative 1 times 3x will be negative 3x. I combine that gets me negative 12x. And negative 1 times negative 9 will be positive 9, which is exactly what I wanted. So my quotient here is going to be 3x, and I'm putting it in parentheses, you don't have to, 3x minus 9. So that is proving that x minus 1 is a factor of 3x squared minus 12x plus 9. Why? Because x minus 1 times 3x minus 9 will equal 3x squared minus 12x plus 9. Let's actually write that out. X minus 1 times 3x minus 9 will equal 3x squared minus 12x plus 9. And what that tells me is that x minus 1 is a factor of 3x squared minus 12x plus 9 because I can multiply it by another polynomial. There's no remainder. We'll talk about what it looks like to see a remainder in a little bit. No remainder, and I get exactly the polynomial that I wanted. Well, notice what this is. These are both linear factors. This is x to the 1, and this has an x to the 1. So this makes it really easy to think about what will make my overall function 0. Because I'm just multiplying two things, and each of these things, it's easy to solve for when it equals 0. This will be 0 when x is 1. This takes a little more work, but I can do that, right? This will be 0 when x is 3. And so this actually shows me the roots of my function, which is why finding factors are going to be so helpful. So is x minus 1 a factor of f of x? Yes, because x minus 1 times 3x minus 9 is equal to 3x squared minus 12x plus 9. And the way that I figured that out is using the division algorithm. So I'm going to give you one more to try on your own, and we'll discuss it in class and then work on some more and continually build to make sure that we're understanding all of the things that come out from our division. All right, go ahead and decide whether x plus 1 is a factor of f of x. Go back and rewatch that example if you need to, and make sure that you're understanding what it is you're trying to do. And then go ahead and complete B and C and be ready to talk about it tomorrow.